Welcome to my latest space weather video. The question for today is, does the sun have dead zones? Unlike many of the other space weather channels on YouTube, I actually do real scientific analysis on data and give you the results and show you how I've done it. And today I'm going to take a look at the distribution of sunspots in latitude and the distribution of sunspots in longitude. I'm sure many of you are familiar with this diagram. It's called the butterfly diagram for obvious reasons. It shows the latitude at which sunspots emerge as a function of time for each of a large number of cycles. But the thing to note is that the latitude at which they first start to appear varies from cycle to cycle, as does the rate at which they converge towards the equator. So this basically says that every cycle is different, and you really must take a look at it from that point of view. The problem becomes much more complicated when you include magnetic fields. Here's an image of the same butterfly diagram, but this time indicating the different magnetic polarities of the sunspots. We'll start in the 1980s here, and in the northern hemisphere, positive field was leading the sunspots and negative field was following. But the reverse was true in the southern hemisphere. The next cycle, it reversed again. So that shows that the magnetic cycle on the sun is actually a 22-year cycle, as opposed to the 11-year magnetic cycle. So let's start our analysis by looking at the latitude of solar cycle 25 sunspots. What I've done here is taken the latitude of numbered NOAA regions and plotted them as a function of latitude bands in 10-degree increments. South is on the left, north is on the right. And you can see there is quite substantial differences between them. The south has a higher average latitude of about minus 20.1 degrees, whereas the north has a lower average latitude at about 17.8 degrees. And that's because most of its spots have concentrated in the 10 to 20 degree range, as opposed to about an even number in the 10 to 20 and the 20 to 30 in the southern hemisphere. Next, let's take a look at the convergence rate of these regions. So I've plotted here the latitude of these regions as a function of time, and you can see that in the northern hemisphere that it has actually decreased about 4 degrees over the last couple of years, whereas the southern hemisphere has basically been going towards the equator at about half that rate. So that means that the southern hemisphere will be later to reach the equator than the northern hemisphere, if this trend continues, and that's not, of course, guaranteed. What about the distribution of sunspots in longitude? This is a synoptic map of magnetic fields on the sun for January of 2022, showing the southern hemisphere seems to have far more activity than the northern hemisphere. What you've plotted here is one Carrington rotation of the sun and the latitude that each spot group is associated with. Now, here there seems to be a concentration in the southern hemisphere of sunspots between about 180 and 360 degrees on the Carrington longitude, whereas from 0 to about 150 there seems to be a dearth. The same seems to be true of the northern hemisphere, but there are obviously fewer regions in the northern hemisphere in general. Many of you may be familiar with my Sun Today postings on YouTube. At the end of the month, I put out a summary for the month in terms of the total sunspot number. And you can see each one of these months seems to have a peak in it. Now, I noted that the peak between March and June was 81 days apart, and that's 3 synodic periods. So this seems to be associated with a particular longitude on the sun. So that got me interested in looking at the longitudinal distribution of sunspots and whether there's a pattern here. There has been a long history of people discussing active longitudes on the sun, whether they're real or not, how long they last and how they change. But basically it's an area that's more able to produce sunspots. The question is, along with active longitudes, are there also dead zones, areas that are less able to produce sunspots consistently over time? And is there a difference in these active longitudes and dead spots between the two hemispheres? And how does this change throughout the solar cycle? We did some work back in 2009, a colleague and I, and we found that we thought that these regions drifted over a solar cycle. but we never really had a chance to take a look at that in more detail. So let's start taking a look at the longitudinal distribution of sunspots. First of all, with both hemispheres included, and this is the plot you get. Now what I've plotted here is the sunspot number for the day during a Carrington rotation, and then added them up for all the Carrington rotations. That's why the numbers are quite so large. If you take an average of this, that's that black line, and a 2 sigma variability on that is shown here. Now, this is barely significant. However, there is seemingly a period of increased sunspot activity from about 300 degrees all the way around to 100 degrees, and then an area of reduced sunspot activity from 110 to about 280. Now the question is, how is this distributed between the two hemispheres? First, let's take a look at the northern hemisphere, and you can see that the distribution is relatively flat, and this is what I was expecting for the whole sun result that I just showed you. And there's hardly any hot areas or cold areas. Now, there may be a slight excess marked here with this red arrow and a slight deficit in this blue zone, a dead zone, but nonetheless it's not very, very significant, I must admit. So this is actually, as I say, what I was expecting for the whole sun, and I'm rather surprised that we didn't get it. So that means that the southern hemisphere must have some extreme results to produce the effect that we saw for the total sun. So let's take a look at that. And that is indeed the case. If you look at this plot, you can see there's a large area of significant above average sunspot reduction between 300 and all the way around to 100, and a deficit from about 110 to about 300. And these are significant deficits. They're not just 2 or 3 sigma. These are multiple sigma. So there does seem to be something going on there. There does seem to be an active longitude area in the southern hemisphere, and also a dead zone in the southern hemisphere. And they both seem to be very significant. So this would explain the peak that we keep getting every month in the sunspot number, and then these low periods for the rest of the month. So the peak is equivalent to that hot zone or active longitude, and the deficits are equivalent to one of these dead zones. So what conclusions can we draw from this? The southern hemisphere is the most active so far. We established that earlier, and it's had 57% of the sunspot numbers that have been registered so far during solar cycle 25. The northern hemisphere spots are collapsing towards the equator faster than the south. The longitudinal distribution of sunspots are very uneven in the south, implying that some longitudes are more conducive to producing sunspots than others. The real question we have remaining is, over the rest of the cycle, how will this evolve? Will these deficits and octave longitudes migrate in longitude, or will they stay where they are? Will the low areas start to fill in, or the high areas start to drop? That remains to be seen. Anyway, it should be interesting to follow. You see, I don't have the sophisticated equipment I used to have a decade ago when I was working, so I can't do the same sort of analysis as I did before. However, I'm hoping that somebody will pick up this sort of thing and take a look at it in more detail and come up with some more scientifically firm conclusions based on, say, the magnetic fields rather than just the sunspots. Don't forget, I have a Twitter channel that I put out summaries every day. The Sun Today is a summary of the general solar conditions. Then each evening I put out a CME watch, so you can see the spectacular coronal mass ejections, which may be leading to geomagnetic storms in a day or two afterwards. Then if there's a major flare or a geomagnetic storm, I'll put out some breaking space weather news, and I also do climate updates on that channel. So thank you for watching. If you found this interesting, please pass it on to others who you think might benefit from it. In the meantime, stay safe and goodbye.